Hello, we are Team Nature and we are the creators of the Spill Tracker website. My name is Nick Appa and my majors are computer science and business.
My name is Armani Tufana, and my major is computer science.
My name is Tyler Bartlett. I major in computer science with a minor in mathematics.
And my name is Reggie Johnson, and I majored in computer science and minored in psychology. So today we'll be covering our technical demo, some technical methodologies, the design and architecture of our project, the languages, platforms, and frameworks used, the scrapers, and the APIs to gather the information, and then we'll go over some testing.
Some technical methodologies that we use for this project were Scrum. Scrum is agile development where we do work in 2-week sprints and we keep track of all of that information in Pivotal Tracker. So this is Pivotal Tracker. On here we keep track of all of our stories, epics, and other information of what we have worked on. If we click on one of my user stories, we will show what that will look like. So a user story generally starts off with what the user wants, basically. As a visitor to the site, I like to be able to fill out a quick calculation report that will let me know if a spill is reportable. This, from our demo, this was the quick calculation page. So on here we will have a description of what we need, showing where it's at, and then we'll also have acceptance criteria of what is required. So if a chemical's reportable quantity is reached, then it will return that the spill needs to be reported. And we can see that it's done through that. The labels down there are epics. Epics are kind of the bigger, broader things that user stories go into. So on the right, we had epics for accessing weather information, compiling the list of chemicals, storing chemical data, user management, and calculations. Another technical thing we used was Git. On GitHub, we have our entire repository of all the code that we have written. If we go to the website, github.com, we will be able to see everything that we have worked on, all the files kept in one place. This helps with source control, if there's any errors, and just keeping it all in one place where we can access it. Off to the right, we can see the 4 contributors, myself, Tyler, Armani, and Reggie. Each of us forked this repository, and that is where we did all of our work in, where we then pushed it back up to main, and that is what our website would use. So if we scroll down a little bit, we can see some general information about our site and what we have done. We also have information that if open source or people would like to contribute, they can know what style to use and what information is pertinent for them to join in and code along. On the bottom here, we can see a network graph of GitHub. This shows our branches in which we did our coding on. So we have main, dev, and feature branches that all connect together. Design and architecture. We had a pretty large database. I think probably one of the biggest ones out of all of the groups. On the right, we can see here forms, which is probably about 50 lines long. It means we had 50 different attributes that we're storing for one entity. We also kept track of chemicals, facility chemicals, users, the facilities, companies, and a few other little connecting tables. And this is our ER diagram. We also had a lot of external dependencies when it came to API use and web scrapers. Here we can kind of see a UML or basic flow of how the website worked. So basically the browser would get the website from the internet that had all our HTML, CSS, and JavaScript code on it. We would then go to the web app, which was done by Microsoft ASP.NET Core, where we used Identity and the Entity Framework, and then it connected to all of our APIs. One last thing about our ER diagram or our database is this is not what we initially drafted up. This is probably our 6th iteration. When we started, we had 5, 6, 7 things in there, but then we realized as we were going on that we needed to add more tables. We needed to connect them better. We need many-to-many, just to make sure everything worked right and that we could get the data passed through that we needed. Languages, platforms, and frameworks. So we used quite a few languages. The biggest ones were C#, HTML, JavaScript, and if you can call it a language, SQL. We also use CSS for styling of our pages. I think from GitHub we could see that HTML was the biggest amount of code that we had written for this project. We also used SQL Server, which is a Microsoft created database management system, and that helped us run our database on our website. Throughout the project we followed the MVC methods, which is model view controllers, and that is how we wrote our code in kind of order. So we use C# for the models and the controllers, and then HTML and JavaScript for our views. And then the SQL was used for seeding the data in our database and just setting it up initially. When it came to frameworks, we used ASP.NET and .NET Core 3.1 for our website. We used Microsoft Identity, and that helped us keep track of users and logging in and making sure that there was no issues there. We used the Entity Framework to scaffold all of our information that we got from our database, and we used Razor when it came to the HTML and CS working together. For deployment, we used Microsoft Azure. Most of the website was done through Microsoft or their type of coding and just tools for developers. And then when it came to other dependencies like our APIs and other stuff we needed to make the project working the way it was, we used the HTML Agility Pack for the scrapers, Newtonsoft JSON for our JavaScript and passing information client side. We used Bootstrap for styling, jQuery also with our JavaScript, and then David Shim's QR code JavaScript for our two-factor authentication.
When it came to working with identity, for most of my features, I had to deal with identity. In order for us to create our set of users, we had to understand how to work with identity and ensure that the separate databases were connecting properly. Upon scaffolding our site with identity, we were given a ton of files and had to figure out which ones to adjust and which information to hide. An example user story I had included removing the option of a user deleting their information, but that file was not initially scaffolded out. So in order for me to find that file, I had to run a set of commands through the terminal to make it appear in Visual Studio. Once I was able to bring up the file I wanted, then I was able to edit the file however my team needed. In the case of my user story, I was able to then remove the scaffolded code that was detriment to the user.
Web scrapers and chemical processing. So we achieved this by using the HTML Agility Pack to perform the scraping. There was a few decisions on how to approach this when we first started the project, whether we were looking at maybe using Python, a Python script to write a seed script for the chemical data, until I found the HTML Agility Pack, which I thought was an excellent solution for us, already working in C#, and it allowed us to incorporate that scraping functionality as a admin feature. The web scrapers get the chemical names, chemical CAS numbers, and their reportable quantities off of the EPCRA and CERCLA regulated chemical tables, which I'll show you now. Okay, this is EPCRA's list of extremely hazardous substances that they've published on the Codes and Federal Regulations website, their electronic binder. In this table, it shows all the chemicals they deem extremely hazardous. It lists their CAS numbers, their chemical names, and reportable quantities, their threshold planning quantities, which are a different value that we weren't concerned with for our needs for this project. And the web scrapers are designed to go through this table line by line. They get the CAS number, the name, the quantity. And then I'll show you the CERCLA list of hazardous substances. This is also posted on the Codes and Federal Regulations website, and their table was formatted a bit differently. It shows their hazardous substance names, the CAS numbers, some statutory codes, and RCRA waste numbers, which we weren't concerned about. And then it shows the reportable quantities in both pounds and kilograms. So we had to design the scrapers to filter out the kilograms and fix the formatting of some of the CAS numbers. Like for this one, for example, does not have the dashes in it, which was presenting an issue for us looking up chemical data with one of our APIs. So the way the scrapers were designed were to find the table element by passing in the XPath to that table. I had originally tried to design these looking for table IDs, but those websites had not done unique names for the tables, which made finding that specific table hard. Often the list returned for the tables had multiple tables, and the scrapers weren't pulling the correct information into the project. So by switching to providing the XPath straight to the table, we were able to more straightforward and an easier approach to directly access that data. And if that website were to be updated in the future, we could go back to it and get the XPath again. Our scrapers and chemical processing was designed to try to identify duplicate chemicals. A lot of the chemicals listed in CERCLA's hazardous substance list ended up being duplicates in that they had the same CAS numbers and same reportable quantities, but with a different name. An example of that would be showing a chemical's common name and its chemical makeup name. So that was the same substance that we were concerned about, and we didn't need to show them separately. So we designed it to mark that as a synonym chemical in our database and save it to the chemical that was already existing under that same CAS number and reportable quantity. And the CERCLA hazardous substance table also had a lot of notes, like note characters or HTML characters that the web scrapers would not process correctly originally, which led to our chemical names being wrong. We were able to redesign the chemical processor to find those Unicode or find those HTML code values and convert them to their Unicode equivalent. And on subsequent runs of the scrapers, it would also recheck existing data to look for any differences, so that if the regulated chemical lists were updated in the future and we reran our scrapers, we could find changes and update our database accordingly. So here we've switched over to a local host version of our website to demonstrate the web scrapers. This is a fresh launch after we've reset our databases. We can see there's our 4 seeded chemicals currently, and that we're seeing a note that says the scrapers for the EPCRA and CERCLA lists have not been ran yet. We'll head over to the admin page. And this is where I was talking about the XPath. If it ever changed in the future, we could go to that page and re-get that XPath and enter it here. But for now, these are the defaults. I'll go ahead and run the EPCRA scraper now. All right, so now we can see the EPCRA scraper has finished, and it's prompted us so. And we'll run the CERCLA scraper next. All right, and now we've been prompted that the CERCLA web scraper has finished. And we'll go back to our home page, and we can see that our chemical database has been updated, tracking the 969 chemicals.
To gather chemical information, we're using the PubChem API. The PubChem API is an open chemistry database at the National Institute of Health. We use this to retrieve the rest of the chemical information we need to perform the spill calculation. From the web scrapers that we talked about earlier, the chemical information that we get is the CAS number, which is the chemical universal identifier. With that, CAS number, we're able to use this PubChem API to find the exact chemical that we are needing to find. Some of the information that we get include from the Pug REST API, we get the molecular weight and we get the CID number, the PubChem identification number. With that PubChem identification number, I'm able to send another request to the PubChem View API. This API has more information about the chemical. With this API, I'm able to gather the density of the chemical and the vapor pressure of the chemical. Both of these are necessary for performing the spill calculation. When retrieving data from the PubChem API, we'll get information in many different formats. So we have to create a regex parser in order to correctly parse the data from the PubChem API. Sometimes the chemical will have one density, and sometimes they'll have a range of densities, low to high. With the vapor pressure, sometimes the vapor pressure will come back in pascals, which will need to be converted to mmHg, which is millimeters per mercury. Further down, we'll see that there's also an obscure format that comes in sometimes, and we'll have to be able to parse that out as well. It comes in Pascal, so it also needs to be converted. The next API on here that I use is the MapQuest API. With this API, I'm able to retrieve the geo-coordinates of an address to get an accurate location information. This is important for the spill calculation so that we can get accurate information to the user. The geo-coordinates is important for performing the spill calculation because it allows us to get current and historic weather data retrieval. We use Open Weather Maps API to get the current and historical weather data. We use the free version, which restricts historic weather data to within the last 5 days. Now, for communicating with our users, we use an email delivery service called SendGrid. Now, this service allows us to contact our users and allows our users to contact us for sending requests and different requests for information. We also use this to verify user accounts, to reset passwords, and etc.
For the version history feature of our site, I was able to use the GitHub API to show our users the most recent adjustments to our site. By calling the GitHub API, I was able to retrieve the commit IDs, messages, and dates from our team's main branch on GitHub.
And now to testing. We did a lot of testing throughout the term for this project, but the 3 biggest ones were unit test, JavaScript test, and BDD test. All of which helped us ensure that our calculations and code was working optimally and how it was supposed to. If you have any questions, please feel free to ask. Thank you and have a great day.